Okay, so this is a presentation on the classroom practices of out-of-field and in-field mathematics teachers by myself, Aoife Guerin, and my esteemed colleague, Professor Merrilyn Goos, and we're both from the University of Limerick in Ireland. So we just go on to the next slide. So firstly, Merrilyn will talk about the national programme for upskilling out-of-field teachers of post-primary mathematics in Ireland and the aim of this project. And then I will talk about the methodology and the participants involved in the investigation. Merrilyn will then discuss the productive pedagogies framework, which was used to analyse the classroom practices of the participating teachers. And then I'll present the findings, following which Merrilyn will mention the similarities and differences that were found between these groups of teachers.
So I'll tell you a little bit about this program, the Professional Diploma in Mathematics for Teaching, or the PDMT. Since 2012, the Department of Education and Skills in Ireland has funded this program. It's a national CPD program for out-of-field teachers of mathematics in secondary schools. And it was a large tender. The University of Limerick won the tender, and we led a national consortium of institutions. It's a 2-year university diploma program, which teachers complete part-time while they're still teaching in schools. And a condition of the tender was that we had to design the program so that when these teachers graduate, they are eligible to be registered as fully qualified teachers of mathematics, which is a big incentive for them. It's a really intensive program. It's delivered in an intensive blended learning format. So it consists mainly of university level mathematics, which is delivered entirely online, with some face-to-face tutorials scattered around the country. The mathematics pedagogy components are all delivered face-to-face in weekend workshops or a summer school. And the teachers also complete an individual action research project in their own classroom. So far, there were 6 cohorts funded. We have graduated 1,068 teachers from this program. And we know from national surveys that we've conducted that this has reduced the incidence of out-of-field teaching of mathematics from 48% to 25% of all teachers of mathematics in Ireland. So it's a big change, but obviously it's still not good enough. Most of our efforts in this program went into actually designing and delivering it. It's a large, complex program, and the funding was not for research. It was to deliver the program. But we have carried out research to investigate the impact of the program. Clearly, we want to know that. We want to know the impact on teachers' knowledge, bearing in mind how difficult it is to measure that, their beliefs and their classroom practices. So far, most of the research that we've done has been using surveys or some analysis of teachers' written reports of their action research, and we've published that work. But in this study, though, we were really keen to actually go into classrooms and see and talk to teachers in action. Now, ideally, it would have been good to do case studies of teachers before or early in the PDMT and at the end. For logistical reasons, we couldn't do that. So instead, we used a cross-sectional design, and we looked at 3 kinds of mathematics teachers. Firstly, those who are currently out of field and have never done the PDMT, 2 teachers. Secondly, teachers who were out of field but have done the PDMT and they've been upskilled. And thirdly, teachers who were always in field, so they've always been fully qualified.
So a mixed methods approach was employed in the collection of data in order to provide a comprehensive description of the classroom practices of teachers. So 6 mathematics classes were, by each of the 6 teachers, were observed and recorded in 2 blocks of 3 consecutive classes. So in this presentation, we're just going to focus on 3 of these classes. All of these then are taught at junior cycle level. So the students in the classes would have been in years 1 to 3 of post-primary school. And each of the teachers were in different schools. So we went out into 6 different schools to look at these classes. And the recordings of these classes were then analysed using the productive pedagogies framework, which Merrilyn will talk about later. Before the class then and after the class, we did a pre and post interview with each teacher, and pre-questions included the likes of, let's say, what topic are you teaching in today's class? what are your objectives for the lesson, and if the teacher anticipated any particular challenges. And then the post questions, so some questions we asked in the post interview would be the likes of, how do you think the class went? Is there anything that you were particularly pleased about or that you were disappointed with in the lesson? And questions on teachers' knowledge and their confidence, as well as maybe what they thought of the questions they asked their students, as well as what they thought of the questions their students asked them and their own and the teachers' responses to their students. Then we also asked if they had achieved their objectives and if there was anything that they might change if they were to teach the class again. Another thing, the survey that we gave was the teacher PDMT survey. So that was adapted from Maureen Reardon's study. So she gave a survey to teachers who were out of field but completed the PDMT. She gave them a survey on such items as their mathematics teaching, their approaches, their classroom practices. But here we just wanted to use the PDMT survey to gain demographics for the qualitative data. So such items as their gender, the year they gained their qualification to teach maths, the type of school they were teaching in. So was it a mixed school, mixed gender or not, public school or private, and their experience of teaching mathematics and their approaches to teaching mathematics. And then for the quantitative data, we gave survey on teachers' self-efficacy, teachers' professional community index. And again, so the other part of the teacher PDMT survey looked at items such as the classroom practices of teachers, their mathematics teaching, and how effective that they found their teacher training program. So the teachers, the upskill teachers would have completed the PDMT, so they would be talking about the effectiveness of that program, whereas the in-field teachers would have been talking about whatever program that they had completed. And then we gave a survey on, to teachers asking them on characteristics such as characteristics to do with knowledge and confidence, that were they helping or hindering or having no effect on their mathematics teaching practice. And that was adapted from Stephen Quirk, who's actually currently in the write-up stage of his PhD study on teacher identity. We also gave students surveys on their views of mathematics and their experience of learning mathematics. So then we, in the presentation, in this presentation, the focus is on the video recordings and the survey of the characteristics helping and hindering mathematics teaching practice. So we're going to focus on that throughout the presentation. So we just, oh yeah, thank you, Merrilyn. Okay, so this table shows the participating teachers. So you can see the gender of each teacher, so whether they're male or female, and the group they belonged, so upskilled, which is US, in-field, IF, or out-of-field, OFF. And then how many years experience they had teaching mathematics and the year that they gained that qualification, along with the class level, the class year and level that they taught, and the number of students in the class. So students in Ireland are streamed, in first year it's a common course, so that would be C there that you see in the brackets, and after first year they're streamed into higher level HL or ordinary level OL, and ordinary level being an easier level than the higher. So here we had two out-of-field teachers, both female. One had less than 5 years experience of teaching maths and the other had 6 to 10 years. So the out-of-field teachers there are teacher 3 and teacher 5. We had two upskilled teachers. So the upskilled are teacher 1 and teacher 1 and teacher 4. So one of those had, both of them are male, and both of these teachers, one of them had 16 to 20 years experience of teaching maths and the other had less than 5 years experience. And then finally we two in-field teachers, both male, teacher 2 and teacher 6. One had 11 to 15 years experience of teaching mathematics and the other 6 to 10.
So you'll get to see a little bit more of those teachers later on. But I want to talk about the productive pedagogies framework. We needed a consistent, systematic observation instrument. And so I chose this framework because it's been theoretically and statistically validated in Australian research. It was first used 20 years ago in a very large study of 1,000 classrooms and in a follow-up study 10 years later of another 400 classrooms. at primary and secondary level and across all subject areas. So it wasn't specifically designed for mathematics, but it has been used to observe hundreds of mathematics lessons, not only in those studies, but in other research conducted by other people. The framework has the 4 dimensions that you see here. The 2 in the left column are concerned with the academic outcomes of schooling, and the 2 in the right column are concerned with the social outcomes of schooling. And it was an underlying principle of the framework that both academic and social outcomes are important. Within each dimension, there are a number of elements that you see listed there, and each of these elements is scored on a 5-point observation scale. So I'll just say something briefly about each of them. Looking at the academic dimensions first, the intellectual quality dimension acknowledges that all students deserve to be given intellectually challenging work, so no dumbing down. The connectedness dimension emphasises a number of kinds of connectedness. Firstly, that understanding is built on what you already know, but also understanding is enhanced by making connections between topics in your subject, connections between subjects, and connections with life beyond the classroom. On the right-hand side, in the social dimensions, the supportive classroom environment dimension allows students to have a voice, to regulate their own behaviour, and to feel supported and engaged in their own learning. The recognition of difference dimension was often a contentious one, which wasn't observed so often in classrooms, but it was considered to be an important element of the dimension of the framework. This refers to all students being part of a democratic classroom community.
Oh, sorry. So this table shows the median total score for each group over the course of 3 classes. And again, the maximum possible score there is 5. So firstly, we'll look at each of the separate groups of teachers. So looking down the columns, we can see that each group of teachers scored highest on the dimension of supportive environment, and they scored lowest on the dimension of connectedness. And then if we look at each dimension, so that is going along the rows, we can see that the in-field teachers scored higher than the other groups on 2 dimensions. So that would be the dimension of intellectual quality and supportive environment. The upskilled teachers then, they scored highest on connectedness. So you can see the 1.79, but that's very similar as well to the in-field teachers. And then the out-of-field teachers scored highest on recognition of difference. So they have the 3.1 there. Now that may be due to the fact that the out-of-field teachers were teaching mixed ability classes. And so then the element of inclusiveness, which is the degree to which non-dominant groups were represented, that features in their classroom, where the teachers were focusing on encouraging participation by the weaker students. Whereas in the other 2 groups, the students were streamed by ability, so that particular element didn't arise as much. Also in one of the teachers, the out-of-field teachers classes, she must have picked up on the fact while she was teaching that the frequency of responses by the female students was less than those from the male students. And so she was encouraging participation from female students as well. And because the PDMT mainly focused on teaching mathematics for academic outcomes, we're looking at the detail of the teacher scores in those 2 dimensions. So within the dimension of intellectual quality here, so again, you'll see the elements listed on the top there, the columns. Within the dimension of intellectual quality, out-of-field and in-field teachers showed differences in 3 elements. So higher order thinking, so that's HOT, and the column DK is deep knowledge, and knowledge as problematic, PK. So those have been highlighted there in yellow as you're going down the columns. So as you go down at the column, you can see that in general, the score is increasing from out of field to in field. And what that means in the classroom is it was shown in the level of questions that were posed by the groups of teachers for higher order thinking. In deep knowledge, it was shown in the connections that were established to concepts. And then in knowledge as problematic, that was the presentation of knowledge as being problematic and so open to various interpretations and constructions. And also to note there is that one of the teachers, so the in-field teacher, teacher 2, scored particularly highly on the use of meta-language. So that's providing help in the terminology used in mathematics. Now, that school was a designated disadvantaged school, and so the students in his class would have particularly weak literacy skills. So he focused also on promoting literacy skills there. And in his self-reported approaches to teaching, he did say that he had a word-rich environment. And so we were seeing that what they did self-report in their teaching to some degree was coming through in what we saw when we went out to the classrooms. So here's just some examples then of the questions to show the higher order thinking of the questions that the teachers posed to their students. So we can see there the first set of questions is from teacher 5. So she's an out of field teacher, and she was introducing equations in algebra to first year students. And teacher 4 is an upskill teacher. So we had been out of field but completed the PDMT and is now in field. And he was teaching second year ordinary level students. So then that was continuing with simultaneous equations. And teacher 6 is an in-field teacher teaching second year higher level students. And he was introducing simultaneous equations as well. Now you can see in teacher 6 there, the level of thinking that he was getting his students to engage in is quite high. So the first question, and it was pretty much early on in the class, was one of the first questions that he asked. They had already looked at solving linear equations and quadratic equations. And the first question there he was saying was, which of these equations do you think is the hardest to solve? So we're just looking at teacher 6 there. And why? So most students, as you'd expect, most picked equation number 4. And then once the teacher answered, no, that looks very difficult, but not the hardest, then they followed up with example 3. And then one student eventually said, what about example 2? She thought example 2 was the most difficult, and the teacher followed up with, but that looks the easiest. Why do you pick that one? And then the whole notion of there being 2 variables and how are you going to solve an equation with 2 variables? So then the thinking about what do we need to do there? And so you can also see the level of construction of knowledge that's needed in trying to come up with solving these simultaneous equations. So you can see the level again of higher order thinking increasing as you go down along. So then for classroom, in the dimension of connectedness, out of field teachers and in field teachers showed difference in the element of problem-based curriculum. Okay, and again, you can see the score increasing there as you go down. So it's highlighted. So around 6s for the out of field, then 7 and 9 for the upskilled, and 8 and 10 for the in-field. So in general, increasing as you go from out of field to in-field. And this was evident in the type of problems presented to students with respect to the amount of knowledge construction and or creativity required to solve them. So in the next slide again, then we can see examples of problems that the teachers gave to their students. So teacher 3 is out of field. And that's the first, she was introducing multiplying and simplifying. They had done some simplifying prior. And teacher 1 is upskilled, teaching higher level third year students, introducing patterns. So you have there X, Y, Z. So the pattern repeats every third position. So then the question is asked, what letter is going to be in the 63rd position? And the last teacher there, teacher 2, is in field, teaching second year higher level students Pythagoras' theorem. So he had a diagram of a right angle triangle with squares on each of the sides that had grids. And because they had already kind of talked about the theorem and they had done some little bit prior to this, he was asking how many boxes would they expect to find in the square and the hypotenuse after they had added up the squares in the other 2 squares on the other 2 sides. Okay, so based on what they did, what would they expect to find? And again, the knowledge construction is higher as you're moving down there. So this is part then of a survey that we gave to teachers, asking what helped or hindered or had no effect on their mathematics teaching practice. And you can see the same response pattern is evident for the first 3 questions. We have teacher 3 and teacher 5, both of whom are out of field, said that their practice was hindered by their knowledge of mathematics, their knowledge of how to teach mathematics, and their confidence in their ability to teach mathematics. And then we can see that the other teachers, so the upskill teachers and the infield teachers, said that these characteristics were helping their practice. So both teacher 3 then and teacher 4, teacher 3 is out of field and teacher 4 is upskilled. They reported that their experience of teaching mathematics was hindering their practice. Both of these teachers have the least number of years experience of teaching mathematics among the participants, while the other teachers reported this as a helping characteristic. And then all teachers reported that their experience of teaching other subjects helped in their mathematics teaching practice.
So just to go back to our aim then, which was to investigate similarities and differences between these 3 groups of teachers, because remember, we were interested in what effect the PDMT might have had on those who had been upskilled, that particular group. So there were some similarities between the groups. They all had supportive classrooms, but low connectedness in their lessons. And that matches the pattern that had been found in the original Australian studies. So similar to what Kim said, they've got the relationships, but sometimes nothing to say. Also, we saw that all teachers found that the experience of teaching other subjects than mathematics helped their mathematics teaching practice. But there were some differences. And some of the differences might have suggested that the upskilled teachers, the PDMT graduates, were gaining some classroom skills that were more like those exhibited by the experienced infield teachers. That's the first stop point there. So that was evident in the academic dimensions of their classroom practice, even though there were mixed patterns for the social outcomes. We also saw that difference in the upskilled teachers who saw their mathematical knowledge of teaching mathematics and their confidence as being helpful rather than a hindrance because they've got it rather than lacking it. So this is it's a small study in terms of the number of teachers that we looked at, but we have a lot of data. We've only reported on a tiny part of it yet, and we've only begun just to analyse the data from this study. So there is still a great deal more work to be done.
And so now if anybody has any questions, and we hope you enjoyed our talk.